given function. So we have xy squared minus 5y plus 6. We are going to find the partial derivative of this function with respect to x. When we find a partial derivative with respect to x, we treat every other variables as constants. Other variables, we consider them as constant. So let's do it. So I'm going to write down in the derivative notation. So this is the partial derivative notation, that is del by del x. This is we are finding for xy squared minus 5y plus 6. So we operate this partial derivative operator with all the terms inside the brackets. So this is equal to partial derivative with respect to x, xy squared minus partial derivative with respect to x, 5y plus partial derivative of 6 with respect to x. Now let's do the partial derivative of each of the terms. The first term we have xy squared. So since we are doing the partial derivative with respect to x, we have to consider y squared as constant and do the partial derivative or take the derivative of x alone. So I can pull out the y squared since we are treating that as a constant, and then find the partial derivative of x with respect to x minus partial derivative of 5y. This is both are constant. So when you do the partial derivative of a constant with respect to x, this will be 0. Plus here we already have a constant, 6 is a constant. So partial derivative of a constant is 0. Now let's do the partial derivative, or we just take the derivative of x. Since we already considered the y squared as constant, derivative of x with respect to x is 1. So we get y squared times of 1. So finally we get the answer as y squared. So therefore the partial derivative of the given function is y squared. We will now differentiate this given function. We have y equals e power x times of cos of x squared. So basically we see that it is a product of two different functions. That is, this is an exponential function and this is a trigonometric function. So we have a product of two different functions, which means we apply the product rule. So in product rule, suppose if you are differentiating f of x times of gx, two different functions, both are functions of x, then this is equal to derivative of f of x, then multiply this with g of x plus derivative of g of x, and then multiply this with f of x. So in short form, we can write down this as this is basically f prime of x, that is a derivative of f of x, multiply with g of x plus g prime of x, which is the derivative of g of x, multiply with f of x. So basically, you find the derivative of one of the function, multiply with the other function, plus find the derivative of the other function which you have not differentiated in the first term, multiply that with the other function. So this is the product rule. So let's go ahead and apply the product rule. Let me copy the function over here. We can start from here. We have y equals e raised to the power of x cos of x squared. So I'm going to consider this e power x as f of x and cos of x squared as g of x. So let's find the f prime of x and the g prime of x separately, and then we can substitute into the formula as well. So since we have f of x, we have f of x equals e power x. If I find the derivative of this function, that is f prime of x, this is also e power x, because the derivative of an exponential function is the exponential function. And now we will find the derivative of g of x. So we have g of x equals cos of x squared. Therefore, if you take the derivative on both sides, we get g prime of x. And derivative of cos of x squared is, first we derivative the cos function, which is a negative sign, and then we put the term, that is x squared, multiply this with the derivative of x squared. Basically, we apply the chain rule. So you multiply with the derivative of x squared, that is d by dx of x squared, and this is equivalent to 2x. So basically, we put the 2x here. So g prime of x is equivalent to 2x, or in fact, this is we can simplify this negative 2x sine of x squared. Now we can plug this into this formula. So therefore we can write down dy by dx equals f prime of x times of g of x. We have f prime of x equals g of x multiply with g of x, which is cos of x squared, plus we have to plug in g prime of x, which is negative 2x sine of x squared. So let me put that in the brackets, negative 2x sine of we write down clearly. This is sine of x squared times of f of x, which is e power x. Now, if we observe, we have e power x in both terms. That is, here we have e power x. Here also we have e power x, which means we can factor out the e power x. So after factoring out the e power x, we will have cos of x squared minus 2x sine of x squared. So this is the derivative of the given function y equals e power x cos of x squared.